I think we can start. Right. Is screen visible to everyone? Yeah. Hello everyone. Good evening to everyone. Myself Swapnil Balasaheb Godke, a doctoral research scholar at the Indian Institute of Technology, Roorkee. So currently I'm working as a teaching assistant under the guidance of Professor Sudhir Mishra sir for the development and applications of special concrete. So today's session mostly the theoretical one. I hope you have gone through week 3 lectures. So in the last lecture, one of you has asked you want to see the results of the mercury intrusion porosimetry, right? So in the mercury intrusion porosimetry, we will get the raw data in the form of permeable pore volume percentage and pore inter diameter. As we saw, the smaller the diameter of the pore, we have to increase the pressure to uh, to enter the mercury into in that one. So for that purpose, if you see as diameter goes on as diameter goes on small, we have to increase the pressure this side, and at certain point, sudden increase in the pore volume percentage you will observe. So this increasing point is called as threshold pore size. Means most of the pore volume is occupied by this region after this. So does it indicate the threshold pore size means pore diameter? No. For that purpose, what we have to do, we have to do the differentiation of this graph. Means we have to get the differential intrusion volume. Differentiation of this one, dV by d log d diameter. Once we plot that graph, we'll get like this. And whatever the peak value will get it, that indicates the critical pore size and the maximum amount of pore diameters of this size only, whatever the peak size indicating, and the differential intrusion volume also in that peak value. So what it indicates, the smaller threshold pore size means greater the durability. Smaller the pore size means there is a less amount of possibility to enter the hazardous material into the concrete. So we have the greater durability, but it is not directly indicating the diameter of the pore size. For that purpose, we have to go for the differentiation of this plot. Once differentiation, will get this peak, and corresponding to that peak we'll get the critical pore size, and corresponding to that peak we will also get the differential intrusion pore volume. If you want to see more details about that one, this is the nptel lecture link only, that characterization of construction materials. You can go through this link, this reference for the more detailed explanation, where the concept of mercury intrusion porosimetry along with their results with respect to the different parameters changing in the concrete, such as water cement ratio, cement content, has been explained completely. So in the week 3, now we have started the like special concretes specifically. First of all, we'll see the curing. Everyone knows the curing. So curing refers to the process of maintaining the sufficient moisture and appropriate temperature in concrete during its early age to ensure the proper cement hydration and development of the desired properties. Which are the desired properties? Such as the strength and durability aspects. So, if you don't go for the curing, there is a high amount of moisture loss from the concrete in the early stages of its hydration. So, because of that, that water loss or moisture loss, what will happen? The empty pores will be there, and that empty pores will be responsible for the decreasing strength as well as decreasing the strength as well, and will affect its long-term performance. And it also minimizing the plastic shrinkage. If we has the less amount of pores and will not able to or will not allow the moisture movement from the concrete to the environment, will have the less amount of plastic shrinkage. So if more amount of plastic shrinkage, what will happen? Cracks will be appear in the fresh state itself, right? To avoid that one, we have to be properly cure or properly protect the structure from the direct contact with the environment. So in the last lecture, Professor Mishra sir also has explained that one of students doubt, I think, that does all the particles of cement get hydrated or not? So this is also explained by in this week 3 lectures. So we have the hydration of alite. Alite means C3S phase, that is tricalcium silicate. Once it is in contact with the water, that the thickness surrounding the hydration products goes on increasing. That is indicated by XA. And there is a if it is a diffusion is strong, the water will penetrate through this thickness and then will hydrate the inside substance or inside the cement, whatever that unhydrated cement is looking on that one. But if thickness is more and the water will not able to penetrate that thickness, then unhydrated cement will be in position, will not hydrate proper, will not hydrate completely. So the relation has been given for that one, that is rate of thickness is inversely proportional to the thickness and depend upon the diffusion coefficient, whether it will be diffused through that layer or not. Can anyone tell me the Q? This is suppose this is the column, this is the reinforcement. Does the like curing will be same inside the concrete and the surface of the concrete? No, because there is a difference, because water will not directly contact with the core external water what we are providing the water curing compound, it will be here only. And thing is that another thing, the moisture will evaporate easily from the surface, but if it has to evaporate from the center of the core, it has to travel this much distance, right? So there is a difference between the properties of the concrete on the surface as well as the core. So we have to be keep in mind that it will not always be the same of that one. So what affects the other properties of the dimension stability of the concrete? Temperature is one of the major factor. Relative humidity, wind speed. Wind speed also affects the plastic shrinkage or the early hydration. If wind speed is more because of the air, the drying will happen for very fastly, and the plastic shrinkage or any evaporation of the water will be fast. Internal water loss. So internal water loss means whatever the water available into the concrete will be used for the hydration purposes, right? So hydration purposes, that is called a self desiccation during the cement hydration, affects the strength gain and dimensional stability. Because of the that water has been used, there is a certain amount of empty space will be created, which will be sometimes will be occupied by that hydration products and sometimes will not be occupied. So that's why purpose the curing is very important aspect, to provide the extra water to get that unhydrated cement to get hydrate and fill that empty space and enhance its density or compact microstructure. So what are the different types of curing available? We saw in most of the constructions. What are the curing we saw? Right. So most common is wet curing we saw. We saw on the slabs like rigid pavement. So we saw the ponding will be created, some space will be created and water will be poured on that one. So ponding will be there, wet hedging, cloth covering with the wet sand and sawdust also. That is very common we saw on the flat surfaces basically. Membrane curing, this is also on the flat surfaces, but where it will be used, covering surface with polythene sheeting or waterproofing paper. Anyone? Where we can use the membrane curing instead of the wet curing, or why people are using that one? Because if there is a scarcity of water and less labor also, less quantity of labor, so which will not available to pond that much amount of water, you have to create the like a pond. So for that purpose they will cover the surface with the polythene sheeting. So what will happen, it will not allow the moisture to get evaporate from the surface of the concrete, right? So it will not providing any extra water, but it will not allowing the water itself from the concrete to get evaporate. That's why we are using the membrane curing. Accelerated curing. Accelerated curing means application of heat, that is presence of moisture is very important. High early strength are required for early form mode. Can anyone tell me, if we provide accelerated curing only dry heat, what will happen? Water will get evaporated. Ultimately, whatever the purpose of curing is not will fulfill, right? For that purpose, we have to provide the accelerated curing. That's why we have the water bath where the hot water will be there, and we'll keep the our specimens like cube or cylinder in that one. That is we called as moist curing. Moisture will provide with in that one along with the application of heat. It enhances early strength by enhancing the hydration, early hydration. It provides the early strength, right? Why early strength is required? Why we are providing the accelerated curing, and where will go for this curing, this type of curing, right? Wherever we require to remove the foam up very fastly, we go for the accelerated curing. But what happens? There is a disadvantage of that one. When we go for the high early temperature, may result in lower lateral edge strength and more porosity. Why it happens? Because non-uniform distribution of hydration products, coarser pore structure, and thermal incompatibility. As I said initially, early hydration, like faster hydration because of the heat happens. So that's why thickness of the hydration surrounding the cement particles will be faster growing. And because of that one, whatever the unhydrated cement will be there, that will not able to hydrate in the latter stages. So because of that one, some empty spaces will be remain, which affect its latter edge strength. If complete hydration or most of the cement get hydrated, will get the latter edge strength also. How we will see from the one graph. And because of the empty space, pores will be there, more porosity, there will be a less strength and more permeable concrete, right? So steam curing at atmospheric temperature. Anyone saw this type of steam curing in the industry? Most of the prefabricated elements, they will use this type of curing. So specimens, yeah, right. Railway sleepers, right, right. Like bridge girders, if they want to go for the prefabricated elements, that is also go for the steam curing at atmospheric temperature. But what happens? The steam, the specimens reported to have slightly higher drying shrinkage and moisture movement, because we already saw application of heat should be in the presence of moisture. Steam, there is amount of moisture will be there, but sometimes due to the differential uh, content of the moisture available in the steam, there is a chance to have the higher drying shrinkage and moisture movement. For that purpose, high pressure steam curing is available, that is called autoclaving, where pressure vessel type chamber will be available and wet steam will be applied, and the pressure will be greater than the atmospheric pressure. but it has more advantages like high early strength, high durability, reduced drying shrinkage, moisture movement, reduced efflorescence, improve resistance to external sulfates. But this will be the costlier one, right? So this type of different types of curings available according to the requirement. We have to use that one. Another type of curing is infrared curing. So infrared curing, in this type, infrared radiations are used, and basically in the colder climatic conditions it will be used. So it will provide the rapid strength as well as, but it will not compromise its lateral edge strength. Similar to the what we saw in accelerated curing, we are compromising the lateral edge strength, but in this one, infrared curing will not compromise the lateral edge strength, and normally used for the hollow concrete members. Another type of curing is electrical curing. In this one, what happens? Two external electrodes will be available and will provide the alternating current, AC current. So that's why that AC current will help to enhance the hydration process. But DC will may lead to the hydrolysis of the cement paste. That's why we have to avoid the DC current and we will provide the alternating current. You are not audible properly. Hmm. Okay, is there any heat production in the concrete like that you are? Yeah, it will be there because of the alternating current. It will be there, but don't have exact more idea about this type of curing. But it will be there. Heat generation will be there, but if you want to get more idea, I will explain in next lecture. This one. Okay, or sir, I think sir has not joined. Sir will also join, so he will clear that doubt. Okay. Yeah. So different types of curing methods available according to different types of codes. So Indian Standard Code says some types of curing. Then this is the American Standard Code 68499 2003, which are used for the predicting the 28-day strength of the concrete. That is, first method is called warm method. That is, a water bath is used to conserve the heat during hydration. Then boiling water, method B. That is, boiling water bath is used to provide the additional heat. Autogeneous curing. Curing takes place under adiabatic condition. Adiabatic condition means there is no loss of heat, right? And high temperature and pressure. Externally heat and high pressure supply. If anyone want to go more detail about this one, please follow this code. So we'll get more idea how they are using these methods to calculate the 28 day or predict the 28-day strength of the concrete. So as we see this plot, we have the cubes or cylinder. We first of all, if you go for the curing, that is air curing. We after the demolding, we did not go for the water curing. We kept it in the air itself. If you saw first line, this one, bottom one, and this bottom one line, you see there is a compressive strength below 30 MPa, right? In entirely in his life in the air itself. After 28 days, the strength is increment is almost constant. Up to 365 days, this plot is there. After 28 days, it is almost constant. Above that one, if you go for the second plot, in air after 7 days moist curing. So what happens? 7 days in the water, we kept it for 7 days, and after that, for other period, we kept in the air. So what happens? So certain amount of strength increases, that is more than the air curing. Obviously, there is no moisture evaporation, and after 7 days we kept into the air, there is no change in the strength increment. Then we go for the 28 day. 28 day we observe certain more amount of strength gain, and then we go for the air curing. There is again constant graph we are observing. But if we go for the continuous curing for the 365 days, you see the strength is continuously increasing, right? So what it indicates? So lateral age development strength happens. So that's why curing is more important. Water curing is more important with respect to the getting the required strength or required durability aspects or long-term structural dimension stability. So another concept, yeah, hmm, right, right, because we are not allowing that moisture to get evaporate. Curing means ultimately that is the thing. And as I said, in the core itself, whatever the moisture will be there, if they want to get evaporate, they have to travel longer distance compared to the surface, right? If you are not allowing the surface water itself to get evaporate, the internal water will be at its place. It will not travel anywhere because there is no place to travel, right? Yeah. So another concept is that maturity of concrete. I think most of the peoples know about the maturity of concrete, right? Have you heard in the masters or bachelor's maturity of concrete? So basically, it is indicates the strength of the concrete, which depends on the age of the concrete and temperature of the concrete. That is called the maturity of the concrete, and it has the function like it has the expression that summation of time interval into temperature. And code indicates that datum temperature is usually taken as minus 10 degrees Celsius. So these are the codes. If you want to go more detail about the maturity of the concrete, how it will be conduct in the on the site, that all things. The formula is that m is equal to summation of t minus t0 into delta t, where m indicates maturity factor, which will be in a degree hour, and T the temperature of concrete. T0 we already have datum temperature value which is given as or assume as minus 10 degrees Celsius, and delta T duration of curing period at temperature T hour. So if I give given you some values, can you calculate the maturity factor? Suppose consider temperature of the concrete is 30 degrees Celsius, and if you want to get the maturity factor for 24 days, what will be value of that one? Can anyone calculate? How much? Have you understood the formula, right? Delta T is the what we call duration of a curing period that is given in 24 days. Convert it into hours. So 24 days into how much hours? 24 in 24 days. Yeah, right. 24 into 24. And what will be the value of T? 30 degrees Celsius. And minus datum temperature minus of 10. Hmm. Hmm. So you'll get the value of 2304 in degree hour, right? It indicate the plot will be there according to the maturity and strength of the concrete. And so based on that maturity factor, we can predict the strength of the concrete for that 24 days. So you will see you'll get the more details of that plot in this codes. That AC datum temperature, that no idea about that one. Hmm. I will write your doubts, and in the next lecture I will get off that one. Yeah. Another first of all, one more doubt has been asked. No, that another one is what is that one before that? This is minus 10 datum temperature. Yeah, electric current one. Heat generation due to that one, right? So now we saw curing, and special concretes depend on the temperature. Either the temperature will be low or either temperature will be the high, right? So based on that one, we will have the two types like cold weather concreting and hot weather concreting. So what is the criteria of the cold weather concreting? What is the temperature below? We can say that this is the cold weather concreting, and what is the temperature of the high? We can say this is the hot weather concreting. Any idea? Anyone? 5 degree. So we'll call that cold weather. Okay, right? And what are the special concretes? Why we called it? Can you repeat, please? Hmm. And more, right? Hmm. Okay. We'll see the definitions. What is the temperature value according to the ACI codes? Most of the lectures has been covered by American Standard Codes. So we'll see according to that one what are the conditions. First of all, we'll see why any type of concrete is called as special concrete. Any idea? We have the normal concrete, right? Which has given certain conditions according to the suppose any type of code like Indian standard IS 456. If we consider that has been given certain type of like highest amount of cement content, highest amount of maximum water cement ratio, what we can use according to the strength perspective, according to the durability perspective, right? If any type of concrete material like material conditions, environment, properties, method of placing or condition of placing beyond its normal range, like beyond normal range means whatever the range required for the normal concrete, beyond its normal range, that type of concrete is called as special concrete. So cold weather and hot concrete, it is in B condition, like conditions, environment. It is either these are the environmental aspects. Like if temperature is higher, we call it as hot weather concreting, that and temperature is lower, we call it as cold weather concreting. That's why these are the two special type of concrete, not like a normal concreting, like we can't treat them. So what ACA 306 says about the cold weather concrete? Cold weather is defined as a period when for more than 3 consecutive days the following condition exists. The average daily temperature is less than 5 degrees Celsius and the air temperature is not greater than 10 degrees Celsius for more than one half of any 20-hour period. So understood what ACA 306 for the consecutive 3 days, continuously for 3 days, if the average daily air temperature less than 5 degrees Celsius, we can say it is a cold weather condition. If you want to do concreting, we have to follow certain protocol or certain preparation. We have to do it for that one. And if the air temperature is not greater than 10 degrees Celsius for more than half of any 20-hour period, and particularly if you want to do for the casting on that day itself, then we called it as or treat it as cold weather condition. Understood these two conditions? So why we have to worried about the cold weather conditions? What happens if we go with the same or we treat with the same like a normal concrete? What happens? Does it has the effect on the hydration? Any idea? Cold weather or hot weather? right, right. And in hot weather, the hydration will be the faster because of the temperature effect. So what happens when concrete freezes? We also saw freeze thawing effect in air internment concrete, if you remember, right? So pore water, whatever the available water in the concrete, that is pore water, starts to freeze. If it freezes, whatever is the chemical composition of that pore water or pore solution will changes. That also changes, and pore water freezes. It will occupy more space than the water. How much more space? That is 9% more volume than the water. If it occupies more space, there is no already space available that in that amount. So what happens? It will allow to crack, right? So because of that higher volume compared to the normal water volume, that ice will be responsible to have in generate the crack into the concrete or any detrimental to the long-term integrator detrimental effect to the long-term integrity of concrete. Maybe that cracks will not appear on the surface, but internal cracking will also happen. So as the cold weather is sustained, hydration nearly stops. At what temperature? Below 0 degrees Celsius or that range we'll see at what temperature the hydration will nearly stops, will not hydrate concrete properly or not at all. So strength development in concrete is adversely affected because strength most of the coming from hydration, which will be the hydrated product, calcium silicate hydrate. That will giving the most of the strength of the concrete. So if you saw this plot, we protected concrete suppose for 4 hours, right? We protected concrete for 4 hours. Suppose we go for the hot curing or we give it, and after that we go for the treat. We kept it in the normal frozen condition or normal weather condition. So there you see increase in volume for 4 hours. Although we are keeping into the proper curing condition, after that one also it has the large amount of volume increment, concrete volume increment due to the increase in the water volume. But if you kept it 8 hours, that volume increment is little bit less. If you protect it for 16 hours, that volume increment is more or less. And if we kept it 36 hours, there is almost no effect of freezing condition. So what it indicates means we have to protect the concrete from these conditions, cold weather conditions, in its initial phases. If you protect it in its initial phases, and later on if you kept it in the normal condition, normal weather condition also, there will be a very little or negligible effect on its concrete microstructure or concrete strength development. So that's why we have to be more careful about the initial hydration processes of the concrete, any in cold as well as in hot weather. And this plot is also, yes, yeah, that conditions are there. Will exactly uh, concrete if temperature goes zero, any type of water will freeze, right? Hmm. Right, right, right. Yeah, that data I don't have along with me right now. But whatever the conditions has been given according to the ACI code, that is only given for like below 0 degrees Celsius, not exactly for the pore water. Hmm. Okay. Hmm. So maybe that temperature value will be different, right? That you're asking, no? The freezing value will be different. Yeah, we'll ask. Yeah. Hmm. Yeah, I will ask about that, sir, because I don't found any data about that one. So I don't have any idea about the exact because whatever the code also suggests that is only about the normal water temperature. It's not giving any value about the pore water because it's very difficult to get the pore water. If you want to test also pore solution, not most of the labs are having that equipments to get extract the pore volume, pore water, or pore solution. So it will be very difficult to get that value. But still, I will ask to sir if he has any idea. We'll let you know. Okay. Okay. So you saw this table. The 38 degrees Celsius approximate setting time is around 1 to 2/3 of hours. 32 degrees Celsius, it is 2 to 2/3 of hours. 27 degrees Celsius, 4 hours. Means as temperature goes down, setting time goes on increasing. So hydration slow down. So if you saw nearly at minus 7 degrees Celsius, there at all no setting will observe. The concrete completely stops its hydration at a minus 7 degrees Celsius because most of the water which will be available may be frozen. So there is no water available for the hydration purposes. Yeah, initial setting time. Because I already said most of the care we have to taken only for the initial phases of the hydration. If you saw this plot also, initial phases only affects more. So for that purpose only, this is given for initial setting time only. And more thumb rule is given. So according to the thumb rule, if there is a 10 degree Celsius reduction in the setting time of 10 degree Celsius reduction in the temperature, the setting time of concrete almost doubles. Suppose we have the 20-degree temperature and we are getting the setting time of suppose 1 hour. And if temperature goes down 10 degrees Celsius, like we'll get it 20 to 10. So we'll have the, according to normal thumb rule, we'll get the double the hydration, so or setting time. So how much it will be? 1 2, it become a 2 hours. So this is the thumb rule you can remember. And to prevent the damage due to freezing at early ages before it reaches 3.5 MPa, it is very important according to the American Standard Code 3601.1. What it indicates, up to getting 3.5 MPa strength, we have to be taken care. We have to take care of that curing. Proper curing will be there, like accelerated curing or hot curing. So it will have a less impact of frozen condition on its strength or hydration processes. So, what are the key points we have to be remember? Like to prevent the damage of the concrete due to freezing, it's most important to take care its early stages to ensure concrete develops required strength for safe removal of formwork. So, before removing any type of formwork, we have to understand whether the concrete has been set properly or not. Because in the already in the cold weather condition, hydration will be slow. So maybe what suppose we want according to the Indian Standard Code, suppose we are removing the formwork for the slab for 21 days. Maybe will require more days in the colder weather condition. So on-site visual inspections required for that purposes. Maintain curing condition. Yeah. Hmm. Yes. Yeah. But yeah, yeah. This is for normal only, not air entrance. And we have the limit also air entrance concrete, right? How much it is? Yeah. Yeah. Okay. So that graph is for the normal concrete only, not for air interest. So we have to be like suppose what happens sometimes in the winter, if you see day temperature will be the 10 to 15 degrees Celsius and night it will go around like 1 degree Celsius or below that one also. So there is a drastic change between the day and night temperature. That time also we have to be take care of the concrete or protect the concrete because the large differentiation between the temperatures, what happens? Thermal cracking, there is a high chance of getting the thermal cracking. So that's why We have to be cure a concrete like that wherever the temperature changes will be negligible surrounding to the casted concrete. So properly protected cure concrete can achieve its potential strength even after the later cold exposure. What it indicates, that same graph also means if we initially protected the concrete and cure properly, its latter age frozen condition will not affect its strength. We saw for 36 hours, right? For 36 hours, that will not have any impact of frozen conditions. And during cold weather, external moisture supply generally not required except in heated enclosures. Heated enclosures means dry heat should not provide. The wet steam heat we have to be provide. Then concrete will achieve required strength and durability only if properly produced, placed, and protected. We saw curing conditions only, but there is a certain conditions where the concrete we have to suppose we already casted some place, some structure, and whether we have to cast another structure over it. So there should be a properly produced place and protected. Means we cannot already we have ice on the surface and we cannot pour the concrete on the ice itself. So certain preparation we have to do for that one. We'll see in the upcoming slides what are the preparations we have to do it for that one. Then accelerated hydration reduces setting time, speeds early strength gain, and improves construction efficiency. So accelerating hydration most of the times will be used in the cold weather condition to get the early strength gain and remove the formwork as early as possible. Because we cannot go like if we go with the normal conditions, the construction will go very long period. We have and cost will go increase, right? So we have to be also consider that aspect also. And in some constructions you will see different types of cements, like early hydration cement, faster setting cement will be used, or set accelerating admixtures will be used, which will accelerate the hydration process. So here it has been shown by type 3 cement. This is also according to the ACI code, which indicates type 1, type 2, and type 3 based on their hydration process. And only concrete temperature, not air temperature, governs the effectiveness of protection. So any type of the cold weather concreting or hot weather concreting you are doing, you have to be always note down the temperature of the each material constituents, temperature of the concrete after the preparation, and temperature of the weather, that is lab temperature. So if you want to, if you are producing the concrete into the RMC plant, and if you are going on to the side, you should have the correlation in between that one. So whatever the temperature effects, we have the lab at the RMC plant and lab at the on the site. So according to that one, we have to make certain changes on the site in the hot weather as well as the cold weather conditions. And we saw in the last lecture also, air entrant concrete is required where freezing thawing exposure is expected to avoid the unnecessary damage to the concrete. So what is the preparation we have to do in the cold weather concreting? First of all, whatever the surface will be there, we will remove all the snow, ice from that surface. And that steaming, how will remove that one? Steaming will provide, or hot sand, gravel, insulation will use. But we have to be remember one more thing, that most important, surface in contact with the fresh concrete should be greater than is equal to 2 degrees Celsius and not more than 5 degrees Celsius higher than concrete temperature. Means whatever the surface we remove ice from there or we provide some heat over that surface, the surface temperature goes on increase. So that increase in temperature and the concrete temperature, it should not have a difference more than 5 degrees Celsius. If it is more than 5 degrees Celsius, what happens? If there is a temperature difference between the subgrade and the concrete, thermal cracks, because of the most of the moisture will get evaporated that hot surface from the concrete, and the thermal crack will occur. Another thing is that cold joint. There is no proper bond between two surfaces will happen, right? So weak bonding will responsible for the weak structure or structural integrity of that particular structure. So for that purpose, this condition has been given based on the trials. So we have to be take care of that one. Another thing we have to be consider, like heating of constituents of material. We can heat the water, but they should not be greater than 80 degrees Celsius. Now it is given 80 degrees Celsius, but how we'll find out for our concreting? We have to find out our concreting constituents based on our weather conditions. We cannot, if the code says 80 degrees Celsius means we cannot go for the up to 80 degrees Celsius. Then pipelines and storage tanks must be properly insulated to prevent heat loss until water reaches to the batching plant mixer. Suppose you measure the temperature at the tank and the water is coming through the pipes. So suppose more heat loss is during that process through the pipe. So whatever the actual water you are getting on the batching plant will be different temperature, and the temperature of the tank will be different. So whatever you are noting down, whatever the calculations you are doing for your constituents will not be proper. So you have to be take care of that one also. Heating of aggregates, coarse and fine aggregates may be frozen, so ice lumps will be broken down with the heat and that all things. And maximum that I said, temperature of each constituents. Similarly, heating temperature of aggregate should be clearly defined. Conveyor belts in the RMC plants, batching plants, beans must be adequately insulated. So similarly, three different recommended for cold weather conditions has been given. One is above 5 degrees Celsius, one is above 0 degree, below 0 degree Celsius, and in another one is 5 to 10 degrees Celsius. So if you see above 5 degrees Celsius, it is called as normal condition. So material no need for any heating. Placement temperature maximum 12 degrees Celsius. Insulation not required above 5 degrees Celsius condition. Curing during protection not required. Time of protection not required. And curing after protection, normal water curing has been recommended. But what happens if the ambient temperature is between 0 to 5 degrees Celsius? We have to go for heating of water. Now, whatever the temperature, we have to find out for our mix. Placement temperature minimum 7 degrees Celsius. Concrete to be protected from freezing. Insulation we have to give mineral fiber blankets with thermal resistance. Curing protection not required, and time of protection. So how much time we have to give initial protection for that concrete after the casting? Suppose we are going for the ordinary Portland cement mixture. So 72 hours at 5 degrees Celsius. If temperature is 10 degrees Celsius, 46 hours or 3.5 MPa strength gain. And as we said, there are certain types of admixtures available which can accelerate the hydration process. If you are using that one, this time may get reduced. Suppose we are using any type of accelerating accelerator, so that hydration will be fast, and this for 5 degrees Celsius maybe we have to protect the concrete for 50 hours only. How will understand that one? Minimum. Yeah, yeah, this is only minimum protection period is 72 hours at 5 degrees Celsius and 46 hours at 10 degrees Celsius. But if you are using accelerator, they are saying like it can reduce up to 25 degrees Celsius, 25%. So how we'll understand that one? If we get the 3.5 MPa strength, we after that we can no need to protect that concrete. So max criteria is 3.5 MPa strength according to the ACI code. And curing after protection, no curing if rate of evaporation is very important. If rate of evaporation of concrete, it is 1 kg per square kilometer per hour. If it is greater than that one, then curing protection is required because the water evaporation is very high. Consider it as very high, above 1 kg per meter square per hour. But if it is less than that one, there is no water protection or no curing protection is required. And water can be used if freezing is not expected. Means we based on the weather condition, if freezing is not expected, we can go for the water curing. Otherwise, we can go with the membrane curing, or any type of curing compound we can spray on the surface, so which will avoid the evaporation of the water from the surface to the weather, and will cover that surface as well. Third condition is that sub-zero, means below zero condition. So what it indicates: heating of aggregate and water both required. Placement temperature 7 degrees Celsius. Insulation, similarly for mineral fiber blankets we can use. Curing during protection not required. Time of protection, similar has been given here also. 72 hours at 5 degrees Celsius, 46 hours at 10 degrees Celsius. And, and curing after protection, same condition, 1 kilogram per meter square per hour. If it is less than, we have to no curing condition protection required. And if it is greater than, protection is required. So, so extent of drying in concrete depends on what. If any type of concrete we have casted, so basically curing of concrete after protection period means we protected concrete for this concrete, suppose 72 hours. After that, protection required or not required, what is depend on, or which conditions depend on that one. Extent of drying in concrete, which already depends on temperature of the concrete, ambient air, wind speed, and relative humidity. Then it is necessary, if still after the curing, after the conditions, as we say, this was curing after protection whenever required, 1 kg per meter square per hour. If evaporation rate is greater than that one, only curing protection is required. So we have to observe these things after the protection period. Means after 72 hours for 5 degrees Celsius, we have to observe extent of drying in concrete, limiting evaporation rate, and based on that one we have to decide after protection, after curing, protection is required or not. Another is that this thing will calculate on that, based on this evaporation rate. Yeah, it may be there, because based on the surface area we have to calculate. 1 kilo, I will look into that one. Water curing maybe normally, as we say here also, if it is required, or if freezing condition is not there, we can use the water curing. Otherwise, we cannot use water curing. So this is the cold weather concreting. So what we saw in the cold weather concreting, if we go for the placing, we have to do some preparations. We can go for the material heating also, which a type of water or aggregate. If and curing during protection is very important, specifically for early ages, and depend on that early ages period is depend on the temperature, at what specific temperature we are going for the cast the concrete, suppose 5 degrees Celsius, 10 degrees Celsius. And ultimately the thumb rule is that, what thumb rule says, two condition has been said by thumb rule, remember? Anyone? What thumb rule says: if temperature decreases 10 degrees Celsius, the hydration or the setting time will get double, right? This is the one. And second one is that we have to protect the concrete to, in the initial phases, up to 3.5 MPa strength gain, right? So these two thumb rules we have to be remember. If you don't have any specific equipments to measure the evaporation rate or something like that, so we have to be consider these two aspects, that is thumb rules, these two. So similar to the cold weather concreting, hot weather concreting. So what will happen? We have to go exactly opposite of that one, right? Because neutral temperature is there. Suppose normal concreting temperature. Below is that one we are going for the cold weather concreting. Above that one we are going for the hot weather concreting. So exactly whatever the aspects we saw in the normal cold weather concreting, we have to be seen exactly in opposite manner for the hot weather concreting. So hot weather is a combination of certain conditions which impact, which has a certain impact on the fresh concrete as well as the hardened concrete. What happens, as someone said, like acceleration will be faster. So acceleration will be faster, at the same time the moisture evaporation will be faster, right? So what affects high ambient temperature, high concrete temperature, low relative humidity, and wind speed? These are the considerable factors we have to be note down while doing the hot weather concreting. So extent of drying in concrete depends on temperature of concrete, ambient air, wind speed, and relative humidity. Rate of your, yeah, it's depend on the like we call the place to place. If you saw in India, 38 degrees Celsius is normal, right? You can, yeah. But if you go for the European countries, 38 degrees Celsius very hot for them because cement production or cement type is also different there. So according to that one, they will go for the hot weather protection for that type of 38-degree temperature. So we'll see the temperature conditions in the upcoming slides. So it's depend on the locations. So rate of evaporation is very important factor in the hot weather also and cold weather also. And it is very obvious that in the hot weather conditions, rate of evaporation will be higher than the 1 kilogram per meter square per hour. So that's why we have to go for the, suppose like appropriate curing compound we can spray on the surface, or we can cover the surface with certain blanket to direct contact with the air temperature or concrete temperature, sun temperature. So what it affects fresh concrete? Because what happens, the temperature increases, hydration increases. Hydration increases, to get the same slump, we have to increase the water demand, right? To get the same slump, suppose we concrete, we prepare for the 75 slump, and the temperature is very high. So because of the high temperature, water loss will be there, hydration will be faster, that water will be used hydration purposes, and because of that one, increase in water demand. So rate of slump loss is higher. So because of that one only, we required higher water demand. But higher water demand required, so what will happen? It will impact ultimately on its strength, right? Suppose you design the concrete mix for the 50 MPa, and you are still increasing the water to get the same uh, slump or same finishing of the concrete, you will losing your ultimate strength of the concrete. So we have to be always take care of that, how much extra amount of water we are adding. It should not be beyond the maximum limit based on the code conditions. So there is the increased tendency for plastic shrinkage cracking, because in the plastic state of the concrete, there is a high evaporation of the water in the hot weather conditions. So that's why we'll get the higher amount of plastic shrinkage cracking on the normal concrete. If you saw also, if any type of rigid pavement is constructing on the summer season, there is a very chances to get the cracking on the surface. That's why they we always have continuously water ponding on that surface, as well as some gunny bags will place on that surface. And thermal cracking, because of the temperature difference between the core and the surface, because core temperature will always be the least or less than the surface temperature, which is surface is directly contact with the weather. So if that difference is more, there is a high chances of the thermal cracking. And most of these conditions will happen in the which type of concreting? Mass concreting. Mass concreting, which is like dam. So can we avoid hot weather concreting? No, we can't avoid the hot weather concrete, because we are losing the time also. So we have to take care of the certain preventive measures. And another thing is that most of the Indian scenario, you'll see most of the construction in the summer they will do in the night, because the temperature in the night will be less as compared to the day. So maybe most of the constructions you'll see in the night also in India, in the summer season specifically. Not, I'm not saying about the home or something like that. Most of the large constructions. So hardened concrete. So hardened concrete, already I said the water demand increases, so lower 28 days strength affects is durability aspect also, because of the cracking, shrinkage cracking. So because of the shrinkage cracking, there is a because of the or evaporation of the higher amount of water, there is a chances of the more pores will affect its durability aspects and permeability increment. So these are the uh, like uh, uh, dif- uh, impact of hot weather conditions on the fresh and hardened properties of the concrete. Surface appearance also be variations, because of the slump loss. We will not have the same workability. So for the poor finishability will be there. So that's why greater variations on the surface of the concrete will observe. Conditions you These are the conditions according to the ACI only. So concrete temperature of 10 degree to 15 degree Celsius desirable for good mixed properties, but not always practical. See this condition, but not always practical, means this is the based on the location of the site. Specifications consider regional conditions and generally require concrete placement temperature to be below 29 to 30 degrees Celsius, 32 degrees Celsius. Acceptable temperatures may vary on case to case basis, and values up to 35 to 38 degrees Celsius may be permitted. Because in India, 38 degrees Celsius is very common in the, if you see in the June, July, this is very common temperature, 35. Most of the cities like coastal regions, you will see the constant temperature around 30 degrees Celsius. So this is very common temperature in India. If gone through week 3 lecture, Mishra sir has given one sentence about the codes. Anyone has completed week 3 lectures? He has said about you should have a healthy disrespect about the codes. Healthy disrespect. Healthy means we have that provisions, the peoples have given their inputs, they have tried very hard, got some conclusions and provided compile in the one code format, right? So we have should, that is healthy thing. But disrespect means that should not be always true. It suppose you are getting, as a you are experienced researcher, if you got experience in the concrete construction field and you have found something different results based on the codal provisions, it is not matched with the codal provisions, so you can uh, contact with the code, like India BIS is there. So there is a possibility to change that conditions also. So that's why healthy disrespect. It is not always like code says whatever that will be true, but most of the conditions, as in early stage researcher, we have to follow that condition, right? So working with hot weather concrete. So for that purpose, what we have to do: moist and dry absorptive aggregates, reduce concrete temperature. So how will reduce the concrete temperature? By cooling aggregates and mixing water. These are the two impactful factors: water temperature and cooling aggregates. I think those are from industries. They will see some construction sites will have a chilling plant also, so where they will use the cold water in the concreting. So and aggregates cooling, how on the site most of the times we will have the invent or we'll have the warehouse for the cement, but will not have the warehouse for the aggregates. Aggregates will place onto the like open space only. But in this hot weather conditions, aggregate should be covered, so that's why the temperature will not that much high. Then dampen subgrade. Damper means subgrade should have provide some least amount of water. And if wind condition is very high, wind velocity is very high, the casting place or construction place should be covered with some wind breaks to lower the wind velocity over concrete surface to avoid the higher rate of evaporation. And temporary sunshades, like this type of like most of the people know about the 3D concrete printing is has some booming right now, right? So 3D concrete printing will not have like if you want to go for the lab conditions to the site conditions, there is a high impact of the temperature and the humidity conditions on the printable mix, 3D printable mix. So in that conditions, they have to cover the surface with the sun shades, or they will cast or they will print the building on the roof, so we will not able to print on the like surface. If they want to print on the open conditions, they have to make the necessary changes in the admixtures or in the water content to get the proper flowability and shape stability. So that's why that is also one of the special type of concrete. So it in the hot weather conditions also you have to provide the temporary sunshades to reduce the concrete surface temperature. And we can use the materials and mixed proportions which will be performed well in the hot weather conditions. So what type of material we can use which can perform in the hot weather conditions well? And suppose we are using cement, right? So can we use any material which can reduce the cement generated heat, reduce the cement generated heat? What we can use? Can you repeat, please? Right. Right. Mineral admixtures we can use because they will not directly produce any or will not go into process of the hydration at the initial stages. That will provide the strength in the latter stages. So initially heat will not generate very high. It will reduce the initial heat. So that's why mineral admixtures, fly ash, silica fume, GGBS, rice husk ash, we can use it. And there is a necessary to carry out the trial batches. As I said, we have to carry out the trial batches in the lab. We have to note down all the temperatures. Then we can go to the site, do some mock-up exercise. What we'll measure there also temperature. We carry out some relations, and according to that one, we can make the necessary changes. So it will be vary site to site and location to location, and based on their material constituents, right? Water requirements. Higher water temperature raises concrete temperature. So we have to be careful about the water temperature because higher water demand affects strength, durability, and permeability. Drying shrinkage increases because of the hot weather and responsible for the thermal cracking also. So cool water helps to lower concrete placing temperature and reduces water demand also. So reduces water demand means we'll have the whatever the required strength will achieve on the based on that material constituents or water cement ratio with the using the cool water instead of the required water. If you see, this picture has been the lecture also. Here is the ice, and this is the crusher. So water has been replaced by the ice, crush ice. So ice is going through this one, and it will be crushed, and it will be transported to into the this batching. So it will lower the temperature, concrete temperature ultimately. So in the mixer itself, that will mix with the concrete mix. I think in the last lecture, someone is from Saudi, right? Is there? Yeah, in the Saudi also temperature will be very high. Is hmm? Okay, okay. So to reduce the temperature of the concrete, you will do. Any other particular like protections you will give for the site or not? Okay, 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 according to the Saudi codes. Okay, okay. So you will keep the record of all the constituents temperature, right? Okay, okay. Thank you. So as we said, effect of cement. Cement type influences hot weather performance of concrete because so that's purpose. Hot weather enhances the hydration. So we have to use the cement such type of which has the slower hydration rate. So slower setting cements we called slower setting cements. So it will improve the handling process and reduce the peak temperatures during the early stages of the hydration. So which will ultimately reduce the thermal cracking, early shrinkage cracking also. And another aspect that mineral admixtures also we can use it. We saw the replacement in the last lectures. We saw the replacement how we can do the replacement of the cement with the mineral admixtures. So we can replace the cement content with the mineral admixtures, and we can achieve the same consistency or same slump with the same cement content. Aggregate aggregate gradation and shape should be minimize water demand. So we saw in the last lecture also different types of shapes of aggregate. Suppose we are using the circular aggregates, will require the less amount of water. If you are using different types of aggregate, water demand will be the different because circular size of aggregates will have the less surface area, will have the lubrication effect will be more. So that's why they said blending may be used, means mixture of the aggregates or proper gradation of the aggregates will be used to avoid the extra water demand. Crushed coarse aggregates increases the water demand but improves the resistance to cracking. Supplementary cementitious materials we already discussed fly ash, GGBS, which has the slow setting because we saw the reaction, right? CSH plus how CSH C3S plus H2O is equal to CSH. C2S plus H2O equal to CSH, right? But in the case of the mineral admixtures, what we'll use? Whatever the calcium hydroxide as a byproduct will produce from the cement, that will use along with silica content of this mineral admixtures, and then additional CSH gel will be formed, right? Yeah. So that's why that is the latter strength we are getting from that one. So it's not in initial stages. This mineral admixtures will not take into part in the initial hydration phases. So that's why will not have the peak temperature increment or hydration temperature increment in the initial phases of concrete. And another thing is that here is given fly ash helps to reduce the rate of slump loss in hot conditions. So fly ash is the most probably people are using wherever they don't want to lose the slump loss to maintain the same workability into the hot weather conditions. Because fly ash will have the circular particles, so which will already require a less amount of water to get reduced to enhance its lubrication, as well as another aspect it will another thing is that it will take into part in the latter hydration process. So two aspects will be there. That's why slump loss will be the less in the flash conditions. Another like silica fume also has the circular diameter particles, but silica fume has a very small diameter particles. So small diameter particles will require the means higher surface area. So that's why compared to the silica fume, fly ash will be useful to reduce the rate of slump loss in hot weather conditions. Another aspect, chemical admixtures, water reducing, state retarding admixtures are widely used in hot weather. Water reducing to maintain the same workability at the same water content. State retarding admixtures to avoid the early hydration or early setting to increase the setting time. So because of that one, we are not losing any strength or durability aspects of the concrete. Proportioning, as we saw, the gradation of the aggregate also we are using. So similar manner, we have to be take care of the proportion of the concrete mixing constituents. So what are the proportions? Means cement content should be kept low as possible. while meeting the strength and durability needs, and generally be proportioned for a slump not less than 75 mm. So we have to be considered the 75 mm slump should be there at least while preparing the concrete to get the proper workability condition, proper compaction, proper ship finishing conditions. And thing is that suppose we prepare the concrete in the RMC plant, proposed concrete mixture should be tested under conditions simulating actual delivery time and site environment. What it means, anyone? Because we prepare the concrete into the RMC plant, and then whatever the concrete are coming to the site, we have to be see whatever the suppose we are prepared for the 75 mm slump, we are getting that slump on the site or not. According to that one, I said, as we see, the extra water if required, we are adding into that one, but that extra water should not be beyond the maximum limit of the code. Whatever the code says, maximum water symmetry should that should not be greater than that one. Production and delivery, like scheduled during non-daylight hours in what weather condition, working condition we have to be breakdowns. Suppose continuous concreting, it is there. If it is that into batches, we can break down more critical hot weather conditions. Temperature control. Suppose concrete temperature, if you want to reduce by zero point 0.5 degrees Celsius, how we can reduce that one? Either we can reduce 4 degrees Celsius reduction in cement temperature, or we can reduce to 2 degrees Celsius reduction in water temperature, or 1 degree Celsius reduction in aggregate temperature. So which will be easier one? Water. Obviously, we can get more cool water, and will reduce the overall concrete temperature. Suppose if I want to reduce the overall concrete temperature by 2 degrees Celsius, so how much water temperature we have to reduce? How much? No, for zero point 0.5 degrees Celsius reduction, it is 2 degrees Celsius reduction in water temperature. So if you want to reduce 2 degrees Celsius temperature of concrete itself, so 8 degrees Celsius, right? So means we have to use more cool water as compared to the normal water. So these are the like conditions you have to follow, or conditions you have to follow on the site according to the requirement. And aggregate temperature, we can kept it low using sprinkling or a fog spraying on the aggregate surfaces. Batching and mixing, similar to the normal concrete batching. And yeah, yeah, please. Hmm. No, yeah, actually, what happens now? We can't use ice directly. If you use the ice, uh, certain amount of whatever the cement will get in contact, will start the hydration, and until we get the whole water from the ice itself, will not get the proper hydration of all the cement particles. And once the cement particles which gets the early hydration, some thickness of the layer will form around that CSH, right? That will not able to diffuse that layer. So unhydrated cement amount will be more if you use the complete ice. So that's why if you saw on that picture also, they are crushed. Hmm, 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 hmm. Okay. Hmm, hmm. Okay. Hmm, Yeah, according to the latent heat aspect, it may be correct one. But if you want to utilize whole cement hydration process, it will not be good. And in the lecture itself also, sir has explained that why we have to use the crush that one ice. That's why that in the last slide also you see that one. They are not using complete ice, crushing one, because if you put directly ice into that one, certain water will get melt from that one. That will start hydration. That will create the thickness of the hydrated layer. So whatever the unhydrated cement inside that one, it may after this getting whole water from that ice, it will be very difficult to get penetrate and hydrate whole cement on that one. Ultimately, whole cement will not hydrate, but whatever the requirement of strength we have to get it, that at least should be get hydrated, right? So the code doesn't allow to use directly ice. That's why crush will get it. Okay. I will ask about this thing to sir, but I don't think so. That will be the solution because in the lecture also he's mentioned that one. If you once go through the lecture, maybe your doubt will get clear. Otherwise, I will get solution from him. So you are mainly focusing with respect to the latent heat aspect, right? Yeah, yeah. I will get back to you on that one. So we are seeing batching and mixing. So concrete batching and mixing follow the same good practices as like to the normal conditions. So batching may split or materials layer in the mixture to limit early cement hydration, but it is very careful considerations we have to do while the batching. Mixing time and mixer speed should be minimized to avoid unnecessary heat gain. In the normal Indian conditions, we are not more worried about the mixing time and mixer speed, but it also affects the hydration. So in the hot weather conditions, we should have the minimum mixing time and mixer speed. So how will identify minimum mixing time and mixer speed? It is based on your mix. Once at what mixing time and what mixer speed you are getting the homogeneous mix. So once we get the homogeneous mix, that is the optimum mixing time and mixer speed for your particular mix. It will vary particularly mix to mix. Delivery. Once we prepare the mix, the delivering time should be less. Means in the RMC also, even in the hot weather condition, the RMC plant should be near to the site. So it should give concrete as early as possible once the mixing has been complete. Properly coordinate mixer dispatch with placement rate to avoid delays and waiting, and that schedule major displacement during periods of lower traffic. Means prior, suppose you have the RMC plant at half an hour kilometer, right? Half kilometer you have, and you are expecting this 75 slump. But what happens? Due to they started from there, and due to the traffic, they will come after the 1 hour. So after coming from the 1 hour, the concrete will not be the same, right? So you have to be careful by keeping the like noting how at what time traffic will be less, at what time how much time concrete will come and will have the same slump value at the same from the batch we have at the RMC plant. So that proper planning should be there before going for the actual construction on the hot weather conditions. So that is only called properly coordinate mixer dispatch with placement rate to our delays and waiting, schedule major placements during periods of lower traffic. So most of the times in the night we'll have the lower traffic also, we'll have the lower temperature compared to the day also. So we will go for the night concreting in the case of the hot weather conditions. Plan hot considerations in placing. Plan hot weather placements to minimize exposure to adverse conditions. As we saw in the cold weather, subsurface should be properly uh, remove that ice from that surface. Similarly, in the hot weather conditions also, subsurface will not be too hot. So we have to be careful. But here temperature condition has not given like cold weather condition 2 degrees Celsius and 5 degrees Celsius. But we have to be careful. The surface should not be way too hot as compared to the concrete temperature. So for that purpose, if you are going for the any subgrade which has to be has to be joined with the new concrete, that should be covered with the some sunshades. And for flat work, subgrade should be moist or water sprinkle on that surface, free of standing water. Water should be sprinkled, but it should not be stagnated water over the surface. Slump adjustment. In the I think first lecture, someone has asked about this one, right? Uh, Suppose the mixer will come and extra water will be added or not. So that establish expected slump loss between plant and job site using actual materials should be carried out. We saw in the before slides also. You have to do the trials in the lab. Then you have to do mock-up in the site as well. Not in the large quantity, but in the small quantity. And you have to establish the relation in between that temperatures and your material constituents. And whatever the slump adjustments required according to that relations, you have to do on the site once we get the mix from the RMC plant. Suppose if slump on arrival is below minimum, limited water may be added without exceeding the maximum allowable water content. Which maximum condition according to the code? Suppose we have the European code, we have the Indian standard code, we have the American code. So according to that one, we have to get the maximum water cement ratio condition. We have to follow. We cannot add more water on that one. If yeah, yeah. Mhm. Yeah, certain amount of that strength lose we'll have it on that aspect because if we are already we are adding more, whatever the water required for the mix in the batch itself in the RMC plant, and again we are adding little bit water. Instead of that one, then what code suggests you go for the chemical admixtures which has the hot weather performance. This is the like ultimate or we call last option we have to adding the water because adding the water ultimately we have to compromise the strength. So for that purpose, we have certain now we have very advanced chemical admixtures which can perform according to the conditions of the temperature. Suppose like in hot weather conditions, we have certain type of admixtures. We can use that one, and suppose like a retarder, we use it. We can increase this setting time. So based on the like as you are in the industry, you know based on the experience only, you will go through this type of chemical admixtures and you will use it in your day-to-day construction sites. Retempering. So retempering means refers to the adding water and remixing concrete that has lost workability and become unplaceable. Similar that one already we discussed in the top, but addition of water beyond the specified mix maximum is prohibited. And here also one major aspect they have said effects on strength and other detrimental impacts must be carefully evaluated. Means we are adding water means we are ultimately losing some aspects of the concrete in the hardened concrete such as strength and durability aspects, increase the permeability. But we have to be careful by observing that aspects because if we are not observing or we are not getting care about that one, we will have poor concrete compared to the earlier concrete one. Suppose we have same site, we casted some other beam and some now another beam. We have this different. We made some adjustment of the water according to the conditions. So impact will be different on this two beams. So we have to be carefully evaluated everything. For that purpose only, chemical admixture is the safest option we have. Curing and protection. So protect concrete from high temperature, direct sunlight, low humidity, and drying winds. So high initial curing temperature are more harmful to ultimate strength than high placing temperatures. See carefully, see the sentence. High initial curing temperature. Initial curing temperature, if it is high, it is more harmful to ultimate strength than high placing temperature. Means once we take care of all the conditions of the hot weather placing conditions, but if we are still providing hot weather for the concreting, in the hot water for the concrete curing itself, that will have the major impact as compared to the concrete temperature itself, because that will again enhance its hydration process. Already concrete temperature is high and we are providing high water, so it will enhance its hydration. Early strength or early strength gain will get it because of the early hydration process. So ultimately, all cement will not hydrate. Some force will be remain. Strength will be not achieved as required, and the durability will also get affected. So what it says, concrete should be carefully cured for at least first 7 days with special precautions like waterproof coverings when large day-night temperature variations exist. So most of the like initial also and the sorry, in the cold weather also and hot weather conditions, we have to be take care of the curing conditions in the initial hydration process days, like first 7 days. Here it's saying there in the cold weather we saw almost 36 hours. After that, whatever the temperature changes will be there, that will not have a large impact or negligible impact on the strength or durability aspects of the concrete. So we have to be careful about initial phases only. In the hot weather conditions, moist curing flatwork will use membrane curing flatwork similar to the that one, but water temperature will not be high. Here we can't use the accelerated curing concrete in forms. So in curing of flatwork, most effective for strength development and minimizing early drying shrinkage methods include ponding, wet sand covering, and sprinkling of water. And membrane curing is used when water ponding is not possible, water scarcity is there. That time we'll provide the membrane to avoid the moisture evaporation from the surface itself. Curing of concrete in forms should be covered and kept continuously moist during early curing. Testing and inspection. Here, inspection is very important. Like we saw in the batching plant itself and in the site itself, we have to what inspection we have to do for frequency for slump, air content, temperature, humidity, and unit weight should be higher in hot weather than normal conditions. So we have to inspect that one, such as evaporation rate may be used to validate the results and plan concreting operations for the further casting. Moisture loss should be avoided or protected for that one, and molds should not absorb water or expand when exposed to moisture or immersion. An additional test may be done according to the site conditions to avoid the like curing conditions as well as the fresh state properties conditions such as the workability conditions. Based on the visual inspections and strength gain, you can observe whether we can remove the formwork or not, and at what time we can go for the further construction. Suppose we casted the columns and we remove the formwork, we are seeing the concrete is column is in good condition or good shape stability we have achieved. We got the good hydration according to our visual inspection. But what happens if we at the after certain time we casted the slab itself or we beam itself, we saw creep, right? We saw creep. We remember we saw creep definition. Yeah. So what happens? Creep, certain load in the initial phases comes. So because of that initial load, some deformation will happen, and deformation most importantly happen because of the cementitious contents, not because of the aggregate content. So in the initial phases, if concrete is not properly hydrated whole or through the whole column, like inside, inner also and outer also, there is a high chances to get the deformation. So that's the conditions we have to be visualize, and then we have to take care of that one, and we have to decide whether we can go for the continuous construction or continuous, or we have to wait for certain days. So these are the visual inspection or testing we have to do. You see this type of membrane concrete curing we are doing. This is the membrane placed over the surface of the rigid pavement. Or so this is the like short recap of week 3 lectures. Most of the lectures from the week 3 are like descriptive lectures, which given some like codal provisions, some like rules about the hot weather conditions and cold weather conditions, how to avoid, how to protect if the temperature persists very high, temperature persists very low. So these are the conditions you can remember. You can, once you go through the lectures, you will understand more. So we'll see the questions from that one. So in the context of curing of concrete, consider the following statements. Statement 1, the loss of moisture from concrete aids in the development of its strength. Second statement, the reduction of moisture in concrete minimizes plastic shrinkage and decreases long-term permeability. So can anyone answer this? Hmm. Both correct. Second correct, one false. Anyone? Hmm. Right. Second one. Right. Right. So first one is, hmm, like, I will see. The reduction of moisture in concrete minimizes plastic shrinkage. Reduction of moisture, right? Minimize plastic shrinkage, right? And decreases long-term permeability. Yeah, the answer is wrong. One is true. Sorry, one is false. Two is true. Right? Yeah, yeah. Two is true. One is false. False, false. Yeah, yeah. Reduction in moisture in concrete minimizes plastic shrinkage. Yeah. Mm, false. Understood. So, mm, no, no, not less loss. Moisture content is less. Loss is more. Yeah. So both the statements will be wrong. If you see first statement, the loss of moisture from concrete. We saw in the last lecture the moisture loss. This is the water available from the concrete, and this is a certain amount of pores. This moisture losses means pores will be more, right? So statement one is incorrect, and it affects the strength because pores will be more means strength will be less. And second is the reduction in reducing moisture increases plastic shrinkage and cracking, and there it is given decreasing plastic shrinkage. Okay, so both the statements are wrong. This one, consider the following challenges encounter in the concreting process. One, increase plastic shrinkage. Second, lower slump. Third, increase water demand. Fourth, formation of cold joints. So which of the above problems are caused by hot weather concreting? All. Okay, any other answer? Two. We have to find out the which are the, okay, one. So you are saying only two and three are correct. Okay. So answer four is correct one. What happens? Increases plastic shrinkage. Plastic shrinkage because hot weather, water evaporation will be higher. So because of that one, plastic shrinkage will be there. So one is correct. Lower slump. Lower slump. Already we are saying slump loss will be there because of the faster hydration process. Water demand increases because of the faster hydration. Water evaporation is also there. Water will also utilize for that hydration. So extra water is required to get the same slump value, right? And why formation of cold joints? Because if you are placing concrete, there is a temperature difference between the subgrade and above concrete. So because of that one, cold formation or moisture transfer will be there because of the temperature difference. So because of that one, cold joint formation will be there. So answer will be four, right? Next question: which of the following conditions best define the cold weather period according to ACI 306? We already saw definition of the cold weather. Based on that one only, answer will be here. So can anyone? The first condition is, yeah. Hello. Anyone? Or any other answer? Four, right? We saw exact definition of the cold weather condition according to the ACI 306. Because for 3 consecutive days, the average air temperature is less than 5 degrees Celsius, and the air temperature is not greater than 10 degrees Celsius for more than one half of any 24-hour period. Okay. Next, in the context of shortcutting, which of the following statements is true? This is not related to this week three, but you can see shortcutting. You know, anyone knows shortcutting? Yeah, what is it? Can you explain so everyone can understand? Right. Yeah. Tunneling, lining, we can do with that one. Yeah. So yeah, spray with the hose and pipe will be there. With the pressurize, we'll spray the concrete over this surface above this tunnel lining for purposes. So for that purpose, this, here the options are given: the cement content and size of coarse aggregates. So what will be the answer? The cement content will be high, low. Size of coarse aggregate will be higher or low. What you understood? Because concrete has to. Mm, okay. Mm, answer will be second because cement content should be higher. Either we are reducing the coarse content because size of coarse aggregate we are compromising or reducing because we have to flow the concrete through the pipe, and through the hose nozzle we have to come out of that concrete should be come out and spray over the surface or the lining. And cement content is higher because it should be stick to the surface. So bonding will be good. So answer will be the second. Here explanation you can see higher cement content. Why? Shortcut mixtures typically require an increased binder content or cement content compared to the conventional concrete because higher cement to aggregate ratio provide adhesion means sticky ability. That concrete will be cement will be stick because it is a binding agent. It will the bind to the surface needed for the material to bond to vertically and overhead surfaces without falling off before setting. And lower course aggregate size, as I said, it has to flow through the pipe, hose, and nozzle. It should have the minimum sizes, and it should not rebound while we are spraying on the surface. It should not rebound that concrete course aggregate. For that purposes, we are lowering the size of that one because short kit is also one of the special concrete, and it should have proper flow, proper viscosity. Viscosity will be the major role here. So it should once we spray on the surface, it should get stick. It should not flow down. So we'll see in the upcoming lectures that one. So which of the pair of words can be best used to fill the blanks of the following sentence? An increase in the curing period of the concrete would result in the dash in the strength of the concrete and dash in plastic shrinkage. Okay, anyone? Any other one? So all are agreed with one, right? So increase in the curing period of the concrete would result. We saw that plot also. This plot we saw continuous water curing. Already we are increasing the strength as compared to the air concreting. And plastic shrinkage occurs in the early stages while the concrete is pressed state. So before it has a fully set, water will get evaporate from the surface of the concrete, and it may be due to high winds, high temperature, or low humidity. So because of that evaporation, we'll observe the plastic shrinkage and cracking, right? So that's why both are one is increase and other one is decrease. Now you have to calculate the maturity. We saw the formula, maturity formula. What is the formula of the maturity? We saw that EM is equal to uh, into delta T. Yeah, delta T. And so, can you calculate the maturity of this problem? Curing for 10 days, and the ambient temperature is kept constant for 10 degrees Celsius. So, datum temperature you have to means T0 you have to consider minus 10 degrees Celsius. That is the assumed condition. So, you have all the values. Can you calculate what will be the answer? Okay. Any other? 4800. So, all got the same answer, right? The calculation will be like this 10 minus of 10 into 240 hours because we have to convert the days into hours because unit is degree Celsius hour. So maturity will be no, it's not strength. I will show you the plots in the next lecture. Based on that plot, we can calculate that 10 days strength for this based on the maturity factor. Yeah. We can predict the strength because it's a predicted strength. It's not actual strength. Next question. It is expected that the strength of the concrete determined in the laboratory represent the concrete as place. Now, in the context of shotcrete operations for the collection or preparation of samples, which of the following is true? Again, regarding to the shotcrete, you just think and see what will be the correct answer on that one because we did not Four. Any other? Four is the correct answer. Because what happens, we are not artificially compacting any concrete. Like normal concreting, we suppose we are doing, we are placing the concrete in the column or beam. We will do vibrator to compact or that one, or we'll compact with the hand also. But in the shortcutting, we are already spraying over the surface. So there is a no chance to get compact on that one. In the spraying itself, the pressure itself, it is compacting. And curing, because we can't continuously water place on that one. So curing compound we can place over that surface. So no evaporation of the water from that surface will happen. So that is the answer is the four. The specimen should not be artificially compacted and cure using a curing compound. Okay, understood? So next question is, in the context of cold weather concreting, consider the following statements. Statement 1, concrete with high degree of saturation has better resistance to freezing than concrete with a low degree of saturation. Statement 2, concrete protected and properly cured matures to its potential strength despite subsequent exposure to cold weather. One of the statement we have already saw in the recap itself. So which one you have to find out? Both are true. Any other? Thing is that in the last one, that's the first question also, and in this question also, the wording is like that. You will feel whether it is wrong or right if you see the sentence, but you have to understand the concept behind that sentence. Any other answer, or all are saying both are true? Statement one is false. Why? Any other? Can any now any can think about that one? Statement 2 is correct because we are protecting the surface of the casted specimen, or properly curing we have done, means we can attain its potential strength despite any cold weather conditions. If you are taking care of the all the curing conditions and the placing conditions. But in the statement 1, what it says, concrete with a high degree of saturation. High degree of saturation means higher water content. Basically, you have to link here this concept with the air entrainment, like that. Suppose if you are without air entrainment and with air entrainment, what will happen? Which will be beneficial in the freezing and thawing? With air entrainment, right? Yeah. Here, degree of saturation means higher water content. Higher water content, higher surface area you will require in the freezing condition. Lower water content, lower volume will require to occupy the space. So that's why lower expansion requires, and why high degree of saturation is less resistance to freezing. Only wording is like that. You have to understand that wording. In the exam itself also, you will see this kind, it looks like a correct one. The sentence, its statement one looks like a correct one, but if you see the concept or we understand the properly what is this meaning of the degree of saturation. So in the exam also you will get some questions like this tricky. You understand degree of saturation? Okay. The purpose of get like giving this type of questions, so in the assignment also, and in the exam also, you will be more familiar with this type of questions, so you have to be read properly. Yeah, we can say that because less amount of water. But most of the times, if you don't want to go for the higher strength concreting, low water cement ratio means higher strength concreting, right? If you don't want to get that much higher strength, we have to go with the same normal water cement ratio. Then we will go with the air entrainment. Yeah, we can. Yeah, we can use admixtures also. Water reducing admixtures, we can use it. So next question is, which of the following is not associated with a detrimental hot weather condition? Which one of this one will not associated with the hot weather condition? 3. Anyone? Any other answer? Right. 3. Because hot weather condition, hot concrete temperature will be there. Low relative humidity because of the hot temperature weather condition. Humidity, surrounding humidity will be lower. High amounts of solar radiation because of the sun. But wind speed will not depend on the hot weather condition. It will be different aspect. So that's why option 3. So in the context of curing of concrete, consider the following statements. Statement 1, wet curing is done by ponding the concrete surface with water or keeping it covered with the wet Hessian cloth. Statement 2, membrane curing is used in cases where ponding the surface of concrete does not provide enough water due to higher evaporation rate. What will be the answer now? Both the statements we saw in the recap itself. Hmm. Yeah, right. So both the statements are true, right? Because membrane curing involves applying a polythene sheet over the surface, which avoids the water evaporation. And this particularly adopted in areas with high evaporation rates, water scarcity, or where constant labor intensive water curing is impractical. In these three conditions, we can use the membrane curing. That's why both the statements are true. Next, in the context of cold weather concreting, consider the following statements. When statement 1, when concrete freezes, in addition to freezing of pore water, there is also change in the chemistry of pore water. Second, in sustained cold weather, early hydration of concrete nearly stops, but that does not affect the long-term integrity of the concrete. What will be the answer? Okay. Anyone? Any other answer? Correct. First true, and second one is wrong. Why? Anyone? We already saw first statement. When concrete freezes, it will not only affect the long-term stability of the concrete, it will also affect the pore water, which gets freezes and changes their chemistry. And in the second statement, sustained cold weather, early hydration concrete nearly stops, but that does not affect the long-term integrity. It is contradictory because if early hydration stops, the strength will not gain. Because of hydration only, we are gaining strength, right? If the hydration itself is not happening, how we will say it will not affect the long term integrity? Obviously, it will affect the long-term integrity of the concrete. Long-term integrity means the dimension stability or the damage, all the things like harden properties specifically. It will affect harden properties, right? So that's why statement 2 is wrong, 1 is true. Next, the temperature of which of the following ingredients least affects the temperature of fresh concrete? First of all, understand the question. Which of the following ingredients least affects? Least. Which will affect the minimum temperature of the concrete out of these four? Cement, sand, coarse aggregate, and water. What will be? Okay. Anyone else? Okay. Any other answer is there? This question we all will get confused because we always thought that cement is the higher temperature generation substituent of the concrete, but it is the least one. Why? We'll see. That the temperature of cement has the least impact on the final temperature of fresh concrete, primarily because smaller portion of mixed by weight, typically only 7 to 15%, and coarse aggregate will have 60 to 75%. And additionally, cement has low specific heat, 0.22, compared to the water. So water and coarse aggregate will be the higher impactful factors for the concrete temperature. So even if the cement is quite hot, that is having the less impact on the overall concrete temperature, because most of the students will pick first one will be cement will be the highest one, right? Maybe first thought in your mind also came that one cement will not be the answer, but thing is that the proportion of coarse aggregate will be the higher, and the water, that's why we are if you see, you're decreasing the temperature. If you increasing the decreasing the point 0.5 overall concrete temperature, we are decreasing the water temperature by 2 degrees Celsius, because water has a more impact on the strength. That's why if you see in the hot regions also, chilling plant, because chilling plant, why they are using chilling plant, because impact is more water impact. That's why they are cooling the water and achieving the same concrete slump in the hot weather condition itself. So cement will be the least impact on the final temperature of fresh concrete. Understood? In the context of finalizing the properties of concrete to be used in underwater construction in the laboratory, which of the following statement is correct? This is also not related to the week 3, but any idea? Underwater construction specifically will observe in the like if any bridge we has to construct into the sea or river, you will see the underwater concreting by the Treme method or something like that. 3. Okay, all are agree on 3, or any other answer is there? Answer 3 is correct, because the slump flow test should be carried out in an appropriately designed water tank. We cannot directly go into the river and take the slump value there. So we have to create the design water tank. We have to create the flow similar to that river, and we have to see the slump value in that one. Answer 3 will be correct. So that's all for today. Whatever the questions you have raised, I have noted down, and I will get in contact with the sir, and we will resolve that, and we'll see in the next lecture initial slides what will be the answer for that one. Okay. Meanwhile, once you go through the lectures, some of the questions will get clarified, but still we'll see. Okay. Any other doubt? Anyone? Hello, sir. Okay, sir. Yes, sir. Yes, sir. Yes, sir. Okay, sir. Yes. Yes. Yes, sir. They have some more questions also. I will share with you that one. Yes, sir. Yes. Yes, sir. Yes, sir. No problem. Yes. Yes, sir. Yes, sir. Okay, sir. Sure, sir. Okay. Thank you, sir. Yeah, bye. Bye. Yeah. Okay. Thank you. Good night.